All right, hello, SNC2P sulfate science students. So this week is the week of May 11th to May 15th, and kind of this week's video lesson will be to review all of those examples that I had provided, and hopefully you had found similar answers. And if you didn't, this is again to help you find those answers and what to go wrong. Because this week, what to expect is that you will find a task of 5 different, again, compounds where I will ask you to name them and tell me what their chemical formula is, or actually their chemical symbol is, and who is losing electrons and who is gaining electrons. So that task is going to be on the hub. Again, we'll have 2 questions of 5 marks each, worth 10. Alright, let's begin with sodium bromide. So one of the first things I'm hoping that you did was, if you don't know what the chemical symbol of sodium is, you're going to write Na. That's what it is on your periodic table. And then hopefully you found the one for bromine or bromide. You wouldn't be able to find that on a periodic table. But what do we know that when we are naming these ionic compounds, we change the ending. We change after the first syllable. So we can imagine that an element that starts with bro is bromine. So, and on the periodic table, it looks like this. And let me move over to the side. Is it just NABR? Well, how can we confirm? Let's draw. One of the easiest ways to confirm is draw your Lewis dot diagrams, which is again that electron that's on the outer shell, the valence shell. So I'm looking at sodium on Na on my periodic table. It's in group 1, which means it has 1 valence electron on the outer end. So 1 electron to give away, as it is a metal on the left-hand side. Then bromine, I look for bromine, it's under that 17 number, so it's considered group 7, and that means it has 7 electrons. So 1, 2, 3, 4, 5, 6, 7. How many does it need to become full? 1. So that means it's gaining 1 to become full. It would move over because this is our nonmetal. It's going to gain electrons. And it's a 1-to-1 ratio. 1 electron to 1 electron lost to 1 electron gained. So we keep it NABR. Alright. Let's move on to the next. I'll use a different color so it's not so reddy. Calcium chloride. So let's usually start with the first element that's in a compound, calcium. If you don't know already, hopefully you know that calcium is Ca. Chloride, again, similar to bromide, you wouldn't be able to find the word chloride on a periodic table, but we know that the "ide" part is the second, again, after the first syllable of chlorine, we change the ending when we're naming. So chloride is actually chlorine. Now, again, good to check, always good to check if it remains CaCl, or is there another subscript that we need to check. So let's do the same thing. So let me add Ca, that is our metal. Is calcium in the same group as sodium? It's not. It's actually in group 2. So what that means is there's actually 2 electrons on the outside. So let's write chlorine now. And chlorine, we know, hopefully you know by now, is our nonmetal. It's also on the right-hand side. Just like bromine, it's in group 7, group 7 or column 17. That also means it has 7 electrons in its outer shell. How many spaces does it have left for it to be full? 1. But how many electrons does calcium have to give away? 2. So 1 for sure will go. Well, what's going to happen to the other one? Hopefully you predicted that another chlorine is probably involved. So 1, 2, 3, 4, 5, 6, 7, because there's always 7 electrons in its valence shell. Which means our name is going to just be CaCl2 because 2 electrons had gone to chlorine. Okay, let's keep moving along here. I'll go back to red. Magnesium sulfide. So hopefully you found magnesium sulfide as Mg. Again, same spiel I'm going to give here. You're not going to find sulfide on the periodic table, but you will find sulfur. We know that kind of after the first syllable, we change the ending to "ide." So sulfur on the periodic table is just S. So like most things, we gotta check if there's going to be other subscripts. Just like for calcium chloride, we ended up with CaCl2. Let's find out. So magnesium, a metal, and actually it's directly above calcium. So because they're in the same column, they must have, and they do have, the same amount of valence electrons on the outside. So there's 2. So let us look for sulfur. So sulfur is actually in group 16 there, under the 16, and that means there's 6. 1, 2, 3, 4, 5, 6 electrons. How many let me write non-metal here. How many spots are left over in order for that valence shell to be full in sulfur? So I have my first X, so 1, 2. How many electrons does magnesium have to give away? 2. Which means magnesium remains the same, and sulfur remains the same, as we only needed 1 magnesium and we only needed 1 sulfur. Whereas in the blue question above, we discovered we needed 2 calciums, so that's where our 2 came from. So it stays the same. Let's do 2 more, and then I'm going to actually go down, to where we're given just the chemical symbols. Alright, aluminum oxide. Aluminum oxide. Let's find aluminum, and we see aluminum is Al, but it's actually it's not really found on the left side so much anymore, but it is under the staircase. And then oxide, if you were to guess what element that would be, hopefully you said O for oxygen. Alright, let's draw our Lewis diagrams as we normally do. Aluminum is under 13 over there, so we know the trick is whatever kind of the number it's under, that's usually the amount of valence electrons there are. That's my trick. Or you can count it out, or you can draw your board Rutherford diagram. So aluminum has 3 valence electrons on its outer shell, and oxygen under the number 16 there, and we've already done one with 6 as well before, sulfur, and let's draw 6. 1, 2, 3, 4, 5, 6. Okay, so we've run into something quite different here. Aluminum's our metal, and let's write non-metal. What do we notice about how many electrons our non-metal can accept? How many spaces are left over for it to become full? Only 2. Which means, let's kind of look at our aluminum here. There's 3. So 2, yeah, 2 can go over. But that leaves an extra. And every electron, when we're bonding them together, they must go somewhere. So, logically, if this were to happen, draw another non-metal that would require electrons to be full. So here are my 6. Let's bring that. Let's do another color though. Let's bring one of them over. But wait a minute. Okay, so we gave homes to those 3 electrons of aluminum, but now we still kind of have an extra space on oxygen. Again, when we're bonding, every shell in theory should be full. So draw another aluminum actually. So draw another metal that would be able to give away its electrons. So we knew that aluminum had 3. So let's give one away. Okay, so oxygen is full. Aluminum is full. This aluminum gave its 3 electrons away. Oh my gosh. Now we have an aluminum that has 2 electrons still left to give. So, draw one last oxygen of 6 valence electrons. Because, what do you know? Oxygen with 6 valence electrons has space to gain 2 more. Let's zoom out. Let's go back to our one that we had written. So when writing our formula here, we used 2 aluminum, and we used 3 oxygens. So there is your compound. Alright, let's try one more for this part 1. Lithium phosphide. Lithium. I'm looking for lithium. Li. Phosphide. You wouldn't be able to find phosphide, but you would be able to find phosphorus. And it is just P. Let's move over again. So I know Li, it's on the left side. It's my metal. And phosphorus is on the right hand side. It's my non-metal. I see lithium in group 1. Logically, it means it has 1 valence electron. I see phosphorus under the number 15. So group 5 there. 1, 2, 3, 4, 5. Alright, here we've run into something again. How many spots are open in phosphorus that in order to make it have a full shell? We have 3 available spots for electrons. We look at lithium. How many does lithium have to give away as a metal? Only 1. So let's give away the 1 first. But we still, again, when we're bonding, our outer shells should be full. What do you think we need to do? I'm hoping you said draw 2 more lithiums. Which means, oopsie, our formula will be Li3 phosphorus 1 because we needed the 1 electrons of 2 other lithiums to fill the valence shell of phosphorus. So let's zoom out. So again, those were 5 different examples of using your skills of drawing Lewis dot diagrams and practicing your naming skills. Because I don't want to make this video long, I'm going to do a part 2 of the other chemical formulas down here. But if you wish, get started on that worksheet task. Thanks everyone. Email me if you have any questions.